Hey guys, Mr. B here. I want to teach you a little bit today about how to solve absolute value inequalities. Now, the good news is, if you could solve compound inequalities, then you should be perfectly fine with absolute value inequalities, because we're actually only going to kind of throw in one extra step. First thing we need to do is talk about what does it actually mean to talk about absolute value. So if we said, what number has an absolute value of 3, we would have to say that a number that has an absolute value of 3 would either be 3 or -3. And the reason we have to say that is because absolute value is nothing more than how many units away is that number from 0 on a number line. So both 3 and -3 are both 3 units away from 0 on a number line. So therefore, they would both have an absolute value of 3. When we talk about absolute value inequalities, we're going to be combining the skills that we just learned with compound inequalities. And we're just going to kind of be throwing in some absolute value bars, and really all that does is makes us have to set up the problem ourselves. So what we really need to know is that less than or equal to are going to form ands. And greater than or equal to are going to form ors. Now that's very, very, very important, because if you don't set up the problem correctly, of course your solution's not going to be right, and then therefore your graph is not going to be right. So it's very, very important that you make sure, that you know this information. So I used to always just remember it as, kind of silly here, but I used to remember it as greater is an or, and less than is an and. That's how I always remembered it. So the first thing we do when solving is we first of all make sure that this absolute value is isolated, meaning it's by itself. No number out here in front, no number being added or subtracted over here behind it. It's completely by itself. If it is, we then look at our inequality sign, and that tells us how we're going to set up our problem. So that's a less than or equal to, which tells me it's going to be an and. So what I do is remove the absolute value bars, write down the problem exactly how it stands, and then since it's an and, we have to add the exact same sign, but we're going to negate our answer on the left hand side. Now think about the last slide there where I talked to you about how the absolute value of 3 is 3 and the absolute value of -3 is also 3. So that's why we have to put the negative value on there as well. So then we solve it just like we did the other day. We would add 3 to all 3 parts, which would give us -1 is less than or equal to x, which is less than or equal to 7. And then of course we're going to go ahead and graph that just like we normally would. So we're going to have -1, we're going to have +7, we're going to have closed circles on both of those. And let's see, we would be shading greater than -1, but then less than 7, which means we would be shading in the middle. Alright, let's look at one more example containing a less than symbol. Let's say the absolute value of 2x minus 4 is less than 10. Oops, forgot my sign. Less than 10. Now, again, we're going to first of all make sure that the absolute value is isolated, and if it's not, then you would have to get that absolute value by itself. And I will show you an example of that here in a little while. Since this is already by itself, we're going to go ahead and look at our symbol, which is strictly a less than this time, which still is an and. So we're going to say 2x minus 4 is less than 10, and then we're going to put the exact same symbol, and we're going to put -10. So we're going to add 4 to all 3 parts. So that's going to give me -6 less than 2x less than 14. I'm going to divide everything by 2. That's going to be -3 less than x less than 7. And again, we're going to go ahead and graph. So it's negative 3, it's positive 7, open circles, we'd be shading in the middle. So again, most important part of solving an absolute value inequality is making sure that the absolute value is isolated, and then looking at your sign, your inequality sign. That inequality sign is what's going to determine how we set up our problem. Do we want to set it up as an and, or do we want to set it up as an or? So that's the most important thing that we need to consider. Alright, a few more examples for you. This time I want to look at the absolute value of 2x minus 3 is greater than 7. Greater than 7. Okay, so this time I see a gray TOR sign, which means I'm going to have to set this up as an OR. So remember, ORs are solved as two completely separate problems. So we would just set up 2x minus 3 is greater than 7. That's our first case. Then we write the word OR, and then we write 2x minus 3. Now, here's the tricky part. When we're setting up an OR, you get rid of the absolute value bars, you write down what's inside of it, and then you reverse the inequality sign, and you also negate it. So make sure you got that. You reverse the inequality sign, and you negate the answer. And then you go ahead and solve it like two separate problems. So adding 3 and adding 3 would give me 2x is greater than 10. I'm dividing by 2, so x is greater than 5. I'm adding 3 and adding 3, so 2x is less than 4, negative 4, and divided by 2, x is less than negative 2. Now, if I'm going to graph that, I'm going to have to put negative 2 on the left, and I'm going to have to put 5 on the right. There would be open circles on both of those. The greater than 5 says, you know what, we need to go to the right. And the less than negative 2 says we're going to go to the left, to the left. Everything you own in the box to the left. Okay. Another example. Let's get a little trickier this time. Let's say 2x minus 5 is greater than x plus 1. Now, first thing I check for is the absolute value isolated? And it is. So that means I can go ahead and set up my two problems. So I look at this, that's a gray TOR, so that tells me it's an OR. So I'm going to have 2x minus 5 is greater than x plus 1, or 2x minus 5 is less than, remember, reverse the symbol, and now negate. Now, here's the problem. I need to negate everything to the right of that inequality sign, which means I need to put the negative sign and then the x plus 1 in parentheses. Now I'm ready to solve. So here I'm going to subtract 1x and subtract 1x. That's going to give me 1x, or just x, minus 5 is greater than 1. I'm going to add 5 and add 5, and that's going to give me x is greater than 6. Over here, now that I have to negate everything to the right, I'm going to have to apply the distributive property. So it's going to be 2x minus 5 is less than negative x minus 1. So this time I'm going to add x to both sides. I'm going to get 3x minus 5 is less than negative 1. I'm going to add 5. So 3x is less than 4. Uh-oh. This one doesn't come out so nice for us. It leaves us with 4/3. Now, you could divide that out on your calculator if you want to, write your answer as a decimal. I tend to leave my answers as fractions unless the directions would tell me to have my answer as a decimal, and the reason I choose that is because fractions are exact answers. When we write things as a decimal, we tend to round or leave out a digit or whatever it might be, and then our answer is no longer exact. Therefore, if we were to do the check step, it wouldn't work. So just careful with that. Alright, let's look at one last example. Let's look at 2 times the absolute value of x minus 4 is less than 6. Less than 6. Now, you've heard me mention in every example now that the very first thing we have to do is check and make sure that the absolute value is isolated. In this case, it is not. Here are your absolute value bars. And this 2 is stuck to the outside of it. So just as we would do before, anytime we want to separate a number from a variable or from an absolute value, it's stuck together, which means it's right now being multiplied. So if we want to undo multiplication, we divide. So before you can make your two separate problems, you must have the absolute value by itself. Now that the absolute value is by itself, I can go ahead and make my two separate problems. So remember, it's going to be x minus 4 is less than 3. This is a less than, which tells me it's going to be an and. So put the exact same sign on the left and put the negation on the left-hand side of the problem as well. So then we're going to add 4, and add 4. That's going to give me 1 less than x less than 7. And if I graph it, put 1, put 7, open circles, whoops, and we're going to shade in the middle. Alright, well, I hope that you got at least a basic foundation of how to solve an absolute value inequality. You're going to do a little bit of practice for me. Before you do that practice, I'm going to leave you with one last question, and this is a Keystone related question. So it's geared toward what you could possibly see on the Keystone exam in regards to absolute value inequalities. I'd like for you to take a few minutes to look at this question, and I'd like for you to have your answer prepared for me tomorrow. So please take a look at that.